Okay, so the big thing over the past couple days, we've been doing the chain rule, and so we left off with example C, and this is a nice problem for us. What two rules do you think we have to use in order to find this derivative? Chain rule and quotient. What do you think I set up first? Do you think I set up the quotient or the chain? So here's how we decide. Here's how we decide, okay? When I plug something in here, say 1, I'll take it to the 4th, then I'll take it to the 6th, and then the very last thing I do is divide. And so because division is the last thing you do, you set up the quotient rule. Now what Darren is referring to is that within the quotient rule, yes, we start by taking the derivative using then the chain rule. But I want you to understand that your outermost setup is the quotient. You see that? So now we will need two derivatives, and those derivatives will both require the use of the chain rule. You have to write small for this one or use a separate sheet of paper, one of the two. In order to find, I have f on top, I have g on bottom. So I use the chain rule to find the derivative of 3x minus 5 to the 4th. So I have u to the 4th, I have 3x minus 5. What are those derivatives? Okay, and so as I multiply them together, I get 12 times u, which is 3x minus 5 to the 3rd power. And then I multiply that by g, which is 2 minus x to the 6th. Great. Now we'll go minus. So now I've got g prime. So now I take the derivative of the bottom, which is 2 minus, u to the 6th and a 2 minus x. What are those derivatives? -1, right? So when we multiply those together, we get a -6. So I'm going to write plus 6 times u, which is 2 minus x to the 5th power, times 3x minus 5 to the 4th power. All over. How do I square the bottom? Very good. So that's what we have, okay? Now, I want to simplify this, and if I'm going to simplify this, I have to look for a common factor that's going to cancel out. What common factor cancels out here? 2 minus x. How many 2 minus x's will cancel out? 5. So these will all be gone. This is going to reduce to 1. This will reduce to 7. Okay? So I now have 12 times 3x minus 5 to the 3rd times 2 minus x plus 6 times 3x minus 5 to the 4th all over 2 minus x to the 7th power. What is now a common factor I could take out? Even more than that. 6 times 3x minus 5 to the 3rd power. I take it out. What are you left with here? 2 times this thing, right? So 4 minus 2x. What are you left with here? All over 2 minus x to the 7th power. And you can see that I have like terms I can combine there, and it was 6 times 3x minus 5 to the 3rd. Because it's not being taken to a power. We took out 3 of them, so it reduces it to 1. So it's just a binomial expression where I can combine some like terms. The negative 2x and positive 3x makes x. And the 4 minus the 5 makes negative 1, all over a 2 minus x to the 7th power. So you can see that sometimes these derivatives are not for the faint of heart. But note that the beloved subject that you hold so dear, namely algebra, is the most difficult part of this problem, right? I mean, the calculus really was no issue. We knew how to take each derivative. We knew to set it up properly. But the actual simplifying piece, that's algebra. And it does jump up and bite us from time to time. Good? Okay. Sometimes you see an example in class where you're wondering, could I get that on my own? Not a bad idea to then sometime, when you're in study hall and don't have anything to do, to write down the problem again and try it yourself and see if you can come up with the same result. It's a good thing to do. Okay, we flip it over. Now we got 3 more examples. We'll finish before lunch. It says let w of x equal that thing, and w prime of 3 is what we want to find. And we're given all these table values. Now, last year, I think that when many of our students encountered these type of problems in the AP exam, they just shut down because I didn't do a lot of examples of them in class. This really isn't that bad of a problem at all. Namely, we have to find w prime of 3. Well, maybe first I should write down w prime of x. And w is defined as a composition function. It says that w is equal to u of v of x. Well, if I want to find the derivative of a composition function, what do? Start by the derivative of the, which is v prime of x times u prime of v of x. Remember, it's the derivative of the outside times the derivative, the derivative of the inside times the derivative of the outside with the inside left alone. See that? So that's my derivative rule. After that, the problem isn't too bad. I plug in 3. W prime of 3 is equal to, what is V prime of 3? Negative 3 times U prime of, now I have to find V of 3. 5. So now I have negative 3 times U prime of 5. What is U prime of 5? Now we're going to look at 2 examples that involve a graph. Blue one is G, red one is F. It says let U of x be equal to F of G of x. Again, a composition function. Let W of x be G of F of x. So I have U prime of x is equal to what? Because I want to find U prime of 1. So I'll write out U prime of x. So following what we did up above, how would you state that derivative? G prime of x F prime of G of x. So now I have G prime of 1. What does that mean, G prime of 1? The slope at 1. So I look for G, that's the blue. I look for the slope at 1. What's that slope? 3. Now I got to find G of 3. I'm sorry, G of 1. What's G of 1? 2. So now I got 3 times F prime of 2. To find the 3 means the derivative of G at 1. So at 1, the derivative of G means the slope. And the slope right there is 3. Because it says to do it at 1. So now I have f prime of 2. -2. No, I did the problem wrong last hour. Nobody said anything. Because we plugged in 2 there because f or g of 1 gave us 2. Whereas when I was doing the problem with them in class, I plugged in 3. And nobody caught it. Oh, well. That's what happens when you teach 2 classes at once. Okay. All right. Let's try the next one. Yep. W prime. So W prime of X is equal to, how do I write that out? Good. All right. What is the value I'm plugging in? -2. What is f prime of -2? What is the slope at -2 for f? Now, right now, I'm looking at g. I want to look at f. F is the red function. What's the slope at -2? 1. Now I got to do f of -2. What is f of -2? 5. Now I got to look at the derivative of g at 5. What is the derivative or the slope of g at 5? 1/4. So you can see those problems are not impossible. They look complicated, but they're really not that bad once we actually work them out. Okay. Last example, find the equation for line tangent. If it says find the equation for line tangent, slope and point on line. I already know the point on line. It's 1, -1. What if I didn't know it was -1? Plug 1 in and see what you get. So we got -1 right there. So how do I find the slope? Take the derivative. Derivative tells us slope. So I'm going to do it without the use of the chain rule. I'm sorry, without writing the boxes. Watch. What's the derivative of the inside? 2. What's the derivative of the outside? 5u to the 4th. So I have 10 times u to the 4th. If you don't like that, then make the boxes and work it out. But you're going to get the same thing. Just generally, most students at some point like to try to do the chain rule in kind of a more of a one-step format, especially if this is a doable one. So what do I plug in? 2 times 1 is 2, minus 3 is -1, to the 4th is 1, times 10 is 10. So y plus 1 is equal to 10 times x minus 1, or y is equal to 10x. So I have a minus 10 and subtract 1, so minus 11. That's the equation for line tangent at that point. Go. Rest time is yours. I sent Miss Nelson 2 cards yesterday. One was from Darren. The card said Miss Nelson's awesome because she's better than Mr. Gentz. So something like that. She liked that one. Yeah, that was her favorite one, she said. Interesting.